Hello, my name is Tim, and I am presenting my course project on diagnosing ADHD. In terms of the opportunity evaluation, what reason did I choose this and what is the core problem? I happen to have ADHD, and I really understand a lot of the troubles that individuals face when both getting an accurate diagnosis for, any neurodiverse condition and understanding some of the problems that come with that, which include only about 20% of people being diagnosed with ADHD who do have ADHD. About 20% of children that are diagnosed are misdiagnosed. And it's also an issue that comes down to not having a lot of centralized data, which is actually one of the reasons why I think this is an attractive prospect for a machine learning solution. There's a lot of data to pull on, even if it's not necessarily centralized. I'll get into some of the pitfalls of this later, but for now, kind of just going into why this would be a great prospect. It's also going to be able to, what would be nice about machine learning algorithms is that's going to be able to cluster information that humans would oftentimes miss, and provides an opportunity to use a neural network to really kind of parse through a lot of these data points. Now, what defines project success for a medical project like this? The most important ones being increasing the rate of individuals who are undiagnosed but do have ADHD, getting more accurate diagnoses for them, identifying symptoms earlier in life to really, help people as they're trying to figure out what their treatment plans are going to be, kind of moving forward, and higher levels of accurate diagnoses, because again, there's a lot of conditions that overlap with ADHD and other neurodiverse conditions. There are several factors to consider as well, including all the different methodologies for diagnosis, triggers for what causes medical providers to test, what symptoms are key signs compared to kind of common overlaps with other conditions, average ages of individuals in getting tested or diagnosed, rates of accurate and inaccurate diagnoses, and what medical systems are currently in use. For me, at least, when I was looking at this, just because of, again, the volume of data, wide variety of factors, and the number of data points, neural networks would definitely be the best approach to this. When training this, however, I was looking at both options for supervised and unsupervised training. And to me, there can be, due to the volume of the data and due to the fact that there are volume of systems that are being used, either labeling them in a supervised data set would be really viable for a model, or unsupervised learning for a different model. And that's why I'm actually arguing, if there was budget and manpower, testing both models because of this reason would be the ideal approach. System design. First off, I chose to go with cloud compared to edge, simply because of the quantity of data from various medical systems. Processing a lot of this data will require large data centers and less so on a localized edge device. And it's going to be a lot easier for integrating APIs, because there are several APIs for all the different systems that are going to be in use. I chose online learning because of, when you have this much data and you have this kind of system, it's very difficult to manually train a system on a regular cadence. Again, per what we learned in class, this is also going to be a cheaper alternative for this much data running through a data center, and it allows the model to remove unnecessary data or out-of-date data, which is very common within the medical industry. And then in terms of online predictions, two of the main factors that kind of everything else rolls out under are medical providers needing to analyze patient data in real time, and then patient safety. So being able to analyze what medications patients are using, what the treatment plans might be, and be able to compare these as they're kind of interacting with a patient. And with that said, there are several model risks to consider. Everything from local to large geos have varying regulations around medical privacy. Again, different countries, the EU, various other organizations, which can kind of cause some issue when it comes to getting all the data we need. Privacy laws, not just for medical information, but privacy laws around any data are getting implemented very quickly after a long period of this not kind of being the case. And so this is going to cause not just for machine learning data, but for a lot of operational standards across a lot of companies. It's going to be kind of a interesting change. Medical data tends to be very personal, so the willingness of patients to sign off on medical data, the cost of purchasing medical data can be quite expensive from my research. There are thousands of systems that are used across, hundreds of thousands of different hospitals. A lot of hospitals, especially in the United States, are not online, so offline or localized records are going to be a problem. And there are several techniques used to diagnose ADHD. Kind of understanding those and understanding where the overlap is with other techniques. Non-cogent treatments, there's a lot of non-scientific treatments for neurodiverse conditions that tend to be promoted by individuals outside of the medical industry that can skew the data. And on top of that, just general misinformation about neurodiversity. With all that said, I want to say thank you for listening to my presentation, and I'm looking forward to hearing about the feedback. Have a great day.